Hey folks, welcome to another VR video. Today I'm going to check out a bit of a detour on the Quest 2. I'm going to check out an application that is in development right now that I discovered through PAX Online and AGX Digital a couple of weeks ago. Now this is a title that is in development for the Quest platform, so it's not exclusive to the Quest 2, as is all Quest content at the present time. So if you have an original Quest device, this application, as well as the entire Quest library, will be available to you. But I decided, since I have the Quest 2 device, that I'm going to check this out on the Quest 2. I'm possibly the first person checking this out on the Quest 2 as well, as the developers don't currently have access to this device. Now, this is an application that is currently in development, so instead of accessing it through the Oculus home storefront here, I'm going to go into unknown sources. I sideloaded this application using the Oculus Developer Hub, which is also how I'm recording this content to my PC at the current time. If you are a developer or you have access to the development platform, I definitely encourage checking out Oculus Developer Hub. But you can also sideload applications through SideQuest VR, which also has a ton of not as curated, but curated content for the Quest and for other VR headsets as well. So the application we're going to jump into today is called Malignancy VR, and it teaches us a bit about cancer. Alright, press trigger when ready. Now, my first reaction to this is this reminds me of, there was a game called Disaster Report that came out, and the text reminds me a bit about that. But let's go ahead and press trigger.
Skin cancer. You may have heard of us, but you can't always spot us. It isn't hard for us to grow through your skin. We can invade the rest of your body. Your lungs are a perfect place for us to grow.
I am inside a lung.
We came here through blood vessels, all the way from that mole on your skin. We can grow freely here. Your immune cells don't see us as a threat.
There's our immune cells, and they don't see them as a threat.
You can't stop us.
Stopping cancer isn't easy, but with the right treatments, we have a chance. I'll let you know when a new treatment is available.
So we've got several different treatments, it looks like.
We'll start with chemotherapy. This treatment is effective at destroying cancer, but can also damage your body. Hold down the trigger to host any cancer cells you can see.
So it says it's effective, but cancer cells quickly become resistant. So let's deploy this on the cancer cells. Now I'm trying carefully not to hit the white blood cells.
Your treatment is effective, but we can grow back.
Now, as you can see, some of the cancer cells are resistant.
Did you think we wouldn't defend ourselves? We are changing, mutating.
Looks like the cancer is resisting chemotherapy. It has cloned more mutated cells that can't be damaged. We need a new treatment. Let's try targeted therapy. It can target and destroy genetically matching cancer cells. This treatment only targets yellow cancer cells. Hold down the trigger to lock onto multiple clones, then release to hit them all at once.
So this, as an educational experience, are our lungs starting to turn black here because we've got so much cancer. But as an educational experience, this is really teaching me about not just cancer, but the treatment for cancer and the horror of cancer, to be perfectly fair. Like, I am trapped inside a lung that is diseased right now. But we're going to target the yellow cells.
Our targeted therapy only works against one mutation. Try to aim for the yellow cells.
You can't target all of us.
That is true.
You can't destroy us all. The cells we have left are enough.
Targeted therapy isn't a match for this mutation. We need a way to fight back against resistant cells. Don't worry, we still have immunotherapy. It exposes cancer cells so your immune system can destroy them. Aim at cancer clones and use the trigger to order nearby immune cells to attack.
Hello, nearby immune cells. And you see the lung is brightening.
Something is wrong. These immune cells shouldn't see us as a threat.
Quick, stop the cancer growth before it's too late.
We just wanted to grow. This is not possible.
Are we sure it's not possible?
This is not possible.
You did it! Your lungs are cancer-free.
We did it. Now, unfortunately, treating cancer is not that.
Everyone wins.
There we go.
Prevention is the best cure. Protect your skin every day.
Now, as I was saying, unfortunately, cancer treatment is not a game. And, so many lose their lives to cancer or are impacted by cancer. Treatment is costly, so, if you have the means to support cancer survivors, don't really treat it as a game and work to prevent cancer. The easiest way to prevent skin cancer in particular is wearing sunblock. But this was an interesting experience, and I'm really glad I had the opportunity to check it out. Thanks again to the developer for sharing this content with me. And it works great on the Quest 2. And while it's a shooter per se, it's a really good educational title for both children and adults. Now, we do have another piece of content that I want to check out today, also on the Quest 2. So we're going to quit out of Malignancy VR, and right here, already in my background here, is the Oculus browser. Now, in Oculus browser, I've pulled up the KaiXR platform. KaiXR does virtual field trips and launched recently. And by clicking on that little cardboard icon, here we are now inside the virtual experience. Now, one of the things I thought was really cool about KaiXR is this is something that you can share with your child. So if you have a child that's being homeschooled, or you're looking for an activity that you can share with your child, this application works on tablets, it works on phones, works on your PC browser. Of course, it plays best because it's mostly 360-degree content inside a VR headset. Now, there are only a couple of the modules available for these field trips that are not locked behind an upgrade wall. So, if you are going to be doing this with a child, definitely I would encourage investing. There's tons of different experiences here that are either pulled in content from other sources. So, for example, Crow the Legend is from another source. It's not developed directly by KaiXR, but it's a Spotlight application. The Lion King, this is an interactive, or I'm sorry, a 360 movie that was available a couple of years back. Portraits of Obama. There's just a huge variety. You've got Kobe Bryant's Last Game, a field trip to Mecca. You've got Super Mario here. You've got Krusty Krab. So all different varieties of content curated, but also in some cases produced by KaiXR. So we're going to jump into the Crispr module here. And it says here it's for ages 12 plus. Credit to KaiXR. That's Kai right there holding what looks like a DNA sequence. And we're going to go ahead and hit play here. And this is about a 7.5 minute experience, it looks like. So again, you can use a phone, you can use a PC, you can use a tablet, but my preference, of course, would be to use a VR headset. In this case, it works great with the Oculus browser on the Quest 2.
CRISPR gene editing is being tested to treat the painful blood disorder, sickle cell anemia.
Sometimes when the pain is really, really bad, it feels like I'm getting bit by a shark.
The groundbreaking technology of CRISPR. It is actually a gene editing tool, and for the first time in the U.S., this technique is now being used to battle genetic diseases like sickle cell.
All right, so we're on the globe, and we seem to be zooming in on California. And right above Silicon Valley there, that's about where I am right now. And we're zooming in on Berkeley, California, which is across the Bay Bridge from me.
Welcome to UC Berkeley. Question: if you could change the DNA in any living thing, would you do it? Why or why not? My name is Kai, and today we're at the Innovative Genomics Institute to explore the gene editing scientific breakthrough CRISPR. But first, what is CRISPR? Let's check our notebook for answers, and I'll meet you inside the lab.
Research shows CRISPR has the potential to cure any disease caused by genetic mutations in DNA. Today, we'll be taking a deeper look into one disease in particular, sickle cell anemia. Sickle cell anemia is a mutation in DNA that changes round red blood cells into sickled crescent-shaped blood cells. As the sickled blood cells circulate through the body, they clog blood vessels and cause unbearable pain. The leading figure of the CRISPR revolution is none other than biochemist Jennifer Doudna.
Hello, future scientists.
Hello,
and welcome
Jennifer.
to our labs at the Innovative Genomics Institute. My name is Jennifer Doudna, and I'm a biochemist. Biochemistry examines the chemical reactions happening inside living things. Today, you'll see how we edit
cool to be in
DNA
this
using
lab.
CRISPR. Good luck today, and don't forget your lab coat.
She was blinging out the lab coat there. That's pretty sweet.
CRISPR can edit the mutation in DNA, eliminating the disease. DNA is a molecule found within all cells that stores its genetic code. To fully understand how CRISPR works, you have to remember to edit. Pay close attention to these 4 steps in our CRISPR editing process.
Insert the
Now,
CRISPR
let's get
into the
started.
cells and test. Okay.
Do you remember how to edit?
I do.
It's
I just
time
read
to
it.
test your knowledge. Scientists usually start the editing process at their desk, examining the mutation in the DNA sequence that's causing the problem.
Step number 1, examine the problem. Scientists examine the DNA, searching for the mutation causing the problem. In this case, we're searching for the mutation in the DNA causing the round red blood cells to change into a sickle shape. A mutation is a change to the DNA sequence of a gene.
Now that they've examined the mutation, next the scientists will design the CRISPR solution.
Step number 2, design your CRISPR solution. Once the problem or mutation is identified and located, scientists design a CRISPR solution. To do this, they design two things: a guide sequence and donor DNA. The guide sequence shows the protein Cas9 where the problem is in the DNA
not
that's
just on the
causing
Quest,
the
but in
sickle
general in
mutation
VR,
of
when
the
it's
red blood
incorporated
cells.
into
The
a
donor
virtual
DNA is
presentation
the
like
correct
this,
version
it's
of the
really
DNA
cool.
containing directions on how to make a healthy, round red blood cell.
Look around. We are now in the tissue culture room where the real lab work begins. After the CRISPR solution is designed, it's time to insert
There's
it
Jennifer's
directly
name right
into the
there.
cell.
Step number 3.
We're already on
Insert
letter I.
CRISPR machinery into cells. For the next step, scientists insert the Cas9 containing the guide sequence and donor DNA that they've designed directly into the cell. The Cas9 acts like scissors when it finds the mutated part of the DNA sequence. In this example, it cuts the mutated DNA sequence that caused the red blood cells to become sickled. The cell's DNA repair team replaces the sickle mutation with healthy donor DNA. The red blood cells will now be the correct round shape.
Do you hear that popping noise?
I do.
That's the sound of the cells being electrocuted, allowing the CRISPR solution to be inserted. We've made it to our final step. It's now time to test our CRISPR solution.
Testing the solution. It's like we were successful.
This brings us to our last step. Step number 4. Test to see if the CRISPR solution worked. Inside the lab, scientists test the cells to see if their attempt to remove the mutation actually worked. In our example,
here we go. We've got
if the tests come back
flowing,
successful,
round
that means
cells
the
again.
DNA mutation causing the painful disease sickle cell anemia was removed and replaced with healthy DNA.
I have the results from our tests. Congrats, future scientists. The test shows the sickle cell mutation was removed.
How did you all do?
Fantastic. We eliminated the mutation in the DNA using CRISPR. Thanks, Jennifer, for letting us visit your labs.
You can come back anytime. I hope you've learned why we're so excited about editing DNA to cure diseases. Students like you will be the next generation of scientists. I'm counting on you all to keep our work going and to decide how to use CRISPR to help people and our planet.
Thanks for joining me at UC Berkeley as we explored the gene editing scientific breakthrough CRISPR. So, if you could change the DNA in any living thing, would you do it? If yes, what would you change and why? Be sure to study your notes and visit UC Berkeley online or in person to learn more about how you can get into the field of biochemistry. Thanks for exploring with me, and I'll see you soon.
And there you have it. That's a quick virtual field trip on the KaiXR platform. You know, again, virtual reality for me is not just about gaming, and I just wanted to highlight a couple of experiences that are educational, that can teach you something. So I hope you've enjoyed this video. I'm going to back out of just this interactive experience here, because what I'm curious about is if we go back to the KaiXR platform, I'm curious what that upgrade cost actually is here. Look at that. So for $12.99 a month, currently discounted to $9.99 a month, again, you can allow your child to have all of these experiences or explore them with your child. Again, I think this is good for home learning, and I think this is good as a way to, you know, encourage that family activity. So get out there and enjoy some VR for yourself. Check out more than just games if you can. Thanks for watching, and I'll see you next time. Bye-bye now.